that's an it seems that it doesn't care what nature is, that it doesn't care what we want to be true. It only cares about what is true. And amen, then. We stumble upon a rule so strange, so absolute, that it feels almost like nature is teasing us. Take the speed of light. That's though at about 300,000 kilometers per second. It certainly wins that race.
No. What's truly peculiar is that it's a limit.
Not a suggestion, not a guideline, but a hard boundary. No matter how clever we are, no matter how powerful machines become, nothing with mass can ever quite reach it, let alone exceed it. Oh, that raises a wonderfully annoying question. Why? Why should the universe impose such a speed limit? But it gets to move at this ultimate pace while everything else must fall short. And perhaps more intriguingly, what would actually happen if we tried to break that rule? I'd like to explore this mystery with you, not by memorizing formulas, but by thinking about what they mean. Richard Feynman liked to show us the real joy of science isn't just in the answer, it's in the curiosity that leads us there. One of the most fascinating things about nature is that it doesn't care what is true. It only cares about what is true. We can argue with it. We can try to outsmart it. We can even build entire theories based on how we think the universe should behave. But in the end, nature always has the final say and presents us with a rule so strange, so stubbornly absolute, that it almost feels like a cosmic joke. Take the speed of light. Now, at first glance, it just seems like a number, an impressively large one, sure. About 300,000 kilometers per second. It can circle the Earth more than 7 times in a single second. That alone is enough to make your head spin. But the real story isn't how fast it is. The real story is that the speed shows up again and again in places where you wouldn't expect it, almost like it's built into the very fabric of reality. What's peculiar, deeply peculiar, is that this speed isn't just about light. It's not just about something zipping through space very quickly. That this number is a kind of universal speed limit. Nothing with mass can reach it. Not electrons, not rockets, not you, not me. It's not yet. You can push harder and harder, add more and more energy. But instead of getting all the way there, you just get closer and closer, like chasing something that always stays just out of reach. Like where things start to get interesting. Because when you first hear this, it sounds like a practical limitation. Like maybe we just don't have powerful enough engines yet. But that's not the case at all. This is not a technological problem. It's a fundamental property of the universe. It's woven into the rules themselves. The most advanced machine imaginable, something far beyond anything we can currently build. You still wouldn't be able to push an object with mass all the way up to the speed of light. Now that's a very strange kind of rule. Usually when we think about limits, we imagine something external, a wall, a barrier, an obstacle in the way. It's a whoa, this isn't like that. There's no physical sign in space that says do not cross. And the closer you try to get to the speed of light, the more nature resists you in subtle and surprising ways. Time begins to behave differently. Distances begin to shift, behaving the way you expect it to. So instead of just asking how fast things can go, we're forced to ask a deeper question. What is it about the structure of space and time that makes the speed so special? Why should there be a maximum speed at all? Why isn't it possible to just keep accelerating forever, going faster and faster without limit? Perhaps even more intriguingly, why does light, something that has no mass at all, move at exactly this speed, no more and no less? These questions push us beyond everyday intuition. They force us to confront the idea that space and time aren't just passive backgrounds where events happen, but active participants in the story. Their own rules, their own geometry, their own way of shaping what is possible and what is not. And when we start to explore these ideas, we begin to see that the speed of light isn't just a speed. It's a kind of boundary between different ways the universe can behave. Boundary isn't just difficult. It would require rewriting the rules of reality itself. And that's what makes it such a beautiful mystery. Not because it stops us, it prevents us to think more deeply about what the universe really is and how it actually works in the playful and curious spirit that Richard Feynman so famously encouraged. Now, if we really want to understand why the speed of light is a limit, we have to let go of a very comfortable idea. The idea that space and time are simple, separate things. It's natural to think of space as a stage where everything happens and time as a clock ticking in the background. The same for everyone, everywhere. But nature, as it turns out, is not so simple and certainly not so accommodating to our intuitions. Imagine you sitting still and someone else is moving past you at a steady speed. Velocity is just that up. If bow forward while riding in a moving car, the speed of the bow from the point of view of someone standing on the ground is just your speed plus the speed of the throw. That's straightforward, almost obvious. But light refuses to play by these rules. Которая длится standing still, riding a train, or traveling in a spaceship at an enormous speed, if you measure the speed of light, you always get the same answer. That's not just surprising, it's deeply unsettling because it forces us to rethink what we mean by motion itself. Behavior was one of the key insights that led Albert Einstein to develop the theory of special relativity. Instead of trying to force light to fit into our old understanding, he turned the problem around. He asked, what must be true about space and time if the speed of light is always the same? What was extraordinary? Time does not flow at the same rate for everyone. The clock's moving relative to you tick more slowly. Space is not fixed either. Lengths contract depending on how fast something is moving. Variants that seem similances to one observer might not be similances to another. These are not illusions or measurement errors. They are real features of how the universe operates. To accelerate an object to higher and higher speeds, you're not just increasing its velocity in some simple sense. You're changing how it experiences time and space. Its speed approaches that of light. Time for that object slows down more and more compared to an outside observer, and distances along the direction of motion shrink. At the same time, something else happens that's just as important. The energy required to keep accelerating the object doesn't increase in a steady, predictable way. It grows more and more rapidly. The closer you get to the speed of light, the more energy it contains. Even a tiny bit of additional speed, it's like climbing a hill that becomes steeper and steeper until it effectively turns into a vertical wall. Reach your point. To actually reach the speed of light, you would need an infinite amount of energy. Not a very large amount, not an impractically huge amount. Infinite. Which is nature's way of saying, very politely but very firmly, no. So the speed of light isn't just a limit because something is physically blocking you. It's a limit because the structure of space and time itself prevents you from ever getting there. The rules change in such a way that the closer you come, the harder it becomes without end. Light, on the other hand, doesn't face this problem at all. It has no mass, and so it doesn't require this infinite energy to move at that speed. It has no choice. It always moves at exactly that speed, as if it lives on the very edge of what the universe allows. And that gives us a different way to think about the speed of light. It's not just the speed of something moving through space. It's a fundamental feature of how space and time are connected, a kind of built-in scale that defines the relationship between them. We are not there this way. The question shifts. We go faster, but what does it mean that the universe is built in such a way that there is a maximum speed at all? A question that keeps pulling us deeper into the strange. and beautiful logic of reality that Richard Feynman loved to explore now. A way to look at this problem, one that makes the speed of light feel less like an arbitrary rule and more like a deep statement about how cause and effect work in the universe. At its heart, physics isn't just about objects and motion. It's about relationships, about how one event can influence another. Suppose it happens, right? You say you clap your hands. That event can have consequences. A fish, manava, waves that travel through the air, vibrations that reach someone else's ears, signals that can be detected, measured, and responded to. In other words, information is being carried from one place to another. Now the question becomes, how fast can that information travel? You might think the answer is as fast as we can make it go. Very gifted opinion about this. There is a maximum speed at which any influence, any signal, any cause can propagate through space. That speed is exactly the speed of light. This is where things start to connect in a really elegant way. For its ocean to travel faster than light, then the order of events could become confused. And that looks like a cause in one frame of reference could appear as an effect in another. In principle, send a signal that arrives before it was sent, creating a kind of loop in time where cause and effect chase each other in circles. And that's not just strange, it's logically inconsistent. Because if an effect could occur before its cause, you could construct all sorts of paradoxes. A message back in time telling yourself not to send the message in the first place. And then what happens? Which both exists and doesn't exist. The universe would no longer have a consistent story. But one way to think about the speed of light is that it protects the order of events. It ensures that causes come before effects, that information flows in a way that keeps the structure of reality intact, like a kind of cosmic speed limit, not just for objects, but for influence itself. With what we've already seen about space and time, something even more interesting emerges. The limit isn't imposed by something external. It arises naturally from the geometry of space-time. The causes time to slow down and length to contract also defines a boundary that no signal can cross. This boundary is sometimes described as a light cone. That's events that can influence each other from those that cannot. Anything inside the cone can be connected by signals traveling at or below the speed of light. Anything outside is forever, or which, no matter how long you wait or how fast you try to go. When we say that nothing can travel faster than light, we're really saying something much deeper. The universe has a built-in consistency, a way of organizing events so that they make sense together. The speed of light is part of that organizing principle, and that gives the whole idea a very different flavor. It's not just about motion or energy anymore. It's about the logical structure of reality itself, about how the universe avoids contradictions and preserves a coherent sequence of events. In this picture plays a special role. It sits exactly on the boundary between what can affect us and what cannot. And limits of causality, marking the edges of what is possible in terms of what is possible in terms of influence and communication. So the next time you think about the speed of light, that not just as a number or even as a physical limit, but as a principle, a rule that keeps the universe from becoming a tangled mess of contradictions. A rule that quietly governs every interaction, every signal, every chain of cause and effect. Richard Feynman. Exploring this makes the speed of light even more that's in a slightly different question. Not just why we can go faster than light, but what it actually means to move at that speed in the first place. Picture about motion. We usually imagine something traveling through space as time steadily ticks forward. A car moves down a road, a plane crosses the sky, a planet orbits a star. There's always this combination of moving through space while progressing through time. At the speed of light, that familiar picture begins to break down in a very surprising way. According to the moves faster and faster. Time for that object slows down. The object slows down relative to an outside observer. This isn't just a small effect. It becomes more and more dramatic as the speed increases. Moving close to the speed of light, you would see it picking slower and slower compared to your own. At the same time, distances in the direction of motion begin to shrink. Space itself seems to compress for the moving object. So you have this strange combination. Time is slowing down and space is contracting, all as a consequence of approaching a special speed. Now push that idea all the way to the extreme. If something could actually move at the speed of light, the equations tell us that time, from its own perspective, would stop completely. Not slow down, stop. There would be no passage of time at all between one moment and the next, and the distance along its direction of motion would shrink down to nothing. Very difficult idea to picture, because our intuition is built on everyday experiences where time always flows and distances are always finite. But mathematically, that's what the structure of space-time suggests. This is one reason why only things with no mass, like light itself, can travel at that speed. They don't experience time in the way massive objects do. They exist, in a sense, right on the edge of space-time, where our usual distinctions between space and time begin to blur. This perspective gives the speed of light a completely different meaning. It's not just a maximum speed in the usual sense, it's a kind of boundary between different modes of existence. On one side, you have objects with mass, moving through time, always experiencing a sequence of moments. On the other side, you have massless entities, for which that sequence doesn't exist in the same way. And this helps explain why absolute. It's not that massive objects are being held back by some external force. Reaching the speed of light would require them to transition into a fundamentally different state, one where the very concepts of time and distance no longer apply in the way we understand them. We can't reach the speed of light. We're really saying that you can't cross that boundary while remaining the kind of object you are. We give up mass entirely and with it the ordinary experience of time. And that's a pretty remarkable thought. Yeah. It suggests that the speed of light isn't just about motion or energy or causality. It's tied to the very nature of existence within space-time. That marks the line between what it means to be a massive object and what it means to be something else entirely. The more you think about it, the matter, the less it feels like an arbitrary rule, and the more it feels like a deep principle, one that connects motion, time, energy, and even identity into a single coherent framework. The framework that reveals just how subtle and surprising the universe can be when you look closely enough in the endlessly curious spirit of Richard Feynman.